In this presentation, we will learn the concept of pointer arithmetic subtraction. So let's get started. Recall what happens when we add an integer to a pointer. Suppose we have a pointer p and an array a, and pointer p initially points to the first element of the array a. That means it contains the address of this element, that is the first element of the array. And what we want to do, we want to add 3 to this pointer. Now recall what happens when we add this integer to the pointer. If we add 3 to the pointer p, then pointer will simply move 3 positions in the forward direction. That is what we have learned in the previous lecture, right? Now my question is, what happens if I subtract 3 from this pointer p? The answer is obvious. Pointer will simply move 3 positions in the backward direction. Isn't that right? That is what is happening when we subtract 3 from the pointer p. Pointer will simply move 3 positions in the backward direction. Now, in general sense, if I say, if p points to ai, then p equals to p minus j is equivalent to address of a I minus j. In our case, I is 3 and j is also 3. Let me replace this I and j. I is 3 and j is also 3. That means, initially p points to a3. That is the fourth element of the array a, right? If we want to perform p equals to p minus 3, then it is equivalent to address of a 3 minus 3. 3 minus 3 is equal to 0. Therefore, pointer will contain the address of the first element of array a. In reality, if we write something like this, p equals to p minus 3, then we first have to know the address which is pointed by the pointer initially. Pointer initially contains the address 1012. Because 1012 is the address of the fourth element of this array. After that, we have to subtract 3 from it. But we cannot directly subtract 3 from it. We have to multiply this 3 by 4. And this 4 represents the number of bytes an integer will take. I'm assuming that integer takes 4 bytes in my computer. That's why I'm multiplying 3 by 4. So if we multiply 3 by 4, we get 12 as the answer. And finally, if we do the subtraction between 1012 and 12, then we get 1000, which is the base address of this array. That is the initial address of this array. My assumption is that the base address of this array is 1000. That is why the address of this location is 1012. When we do the subtraction with 3, we have to multiply 3 by 4 and then we do the subtraction. We then get the result as 1000, which is the starting address or the address of the first element of the array a, right? After understanding this point, let's try to understand what happens when we subtract one pointer from another pointer. Result is distance between the pointers. If we have a pointer p and pointer q which are pointing to different locations of the array, and we want to perform the subtraction between these two pointers, then the result will be the distance between them. We just have to subtract the indices. That is, we can see here pointer q is pointing to the index 6 and pointer p is pointing to index 2. We just have to do the subtraction between 6 and 2. 6 minus 2 is 4, therefore the result is 4. Now we can also do p minus q. Here in this case the result will be negative 4, which I think is understandable. In reality, if base address of this array is 1000, then p contains the address 1008 and q contains the address 1024, right? Because the address of this location is 1008, as 1000 plus 2 into 4 is 1008 and 1000 plus 6 into 4 is 1024, right? Therefore, p initially contains the address 1008 and q initially contains the address 1024. Now, if we want to do the subtraction between these two pointers, then it gives us 1024 minus 1008, which is equals to 16, which is not the correct result, right? The result must be 4, but here we are getting 16. There is something extra in this result. Let's try to remove that extra part. Initially, p contains the address 1008, and we can also write q equals to p plus 4. Isn't that right? Q is the result that we are getting after adding 4 to the p. We can write something like this, q equals to p plus 4, right? What we want to do is q minus p, but let me replace first p by 1008. And we must multiply 4 by 4, right? This is the rule. As we cannot simply add 4 to the pointer, we have to multiply this 4 by the number of bytes an integer will take. As if it is an integer array, therefore we must multiply this 4 by 4, right? So q is equal to 1008 plus 4 into 4. Now let me replace the value of q also. Q contains the address of this particular location, which is 1024, right? What we want to do, we want to subtract q with p. So this is equivalent to 1024 minus 1008. But we want the result as 4, not 4 into 4. So you can easily guess the next step. We have to bring this 4 to the left side of the inequality, that is, in the denominator. And then we will get the result as 4, right? Therefore, whenever we are subtracting the two pointers, we cannot simply subtract their addresses. We must have to divide them by the number of bytes. If the array contains all integers, then we must divide it by the number of bytes an integer will take. If the array contains all characters, then we must have to put the number of bytes a character will take in the denominator. So this is what we should understand related to the subtraction between two pointers. Now let me explain some of the undefined behaviors. Performing arithmetic on pointers which are not pointing to array element leads to undefined behavior. For example, if we have this program in which we have a variable I which contains value 10 and a pointer p which contains the address of this variable I. And what we are trying to do here is we want to add 3 to this pointer p. As this is a variable, not an array, if you try to perform any arithmetic operation with this pointer, then it leads to an undefined behavior. It leads to different outputs every time. This is what we should avoid. This is a variable. After adding 3, the pointer will move 3 positions in forward direction, but we don't know what is there in the subsequent positions, right? As this is a variable, not an array. That is why we get different outputs every time. Also, if two pointers are pointing to different arrays, then performing subtraction between them leads to undefined behavior. For example, if you have an array A and an array B and pointer P points to the first element of the array A and pointer Q points to the first element of the array B, and we want to perform subtraction between these two pointers. The result is undefined behavior. Here I can show that when I run this program online, then I get this output, while when I run this code offline, I get this output. So different outputs every time. That is why it is an undefined behavior. Okay friends, this is it for now. Thank you for watching this presentation.